Hey everyone. So today we would be discussing about the research topic that we have chosen, which is basically textual fact checking using knowledge graphs. Just a brief introduction about us. I'm Shrey Gupta, and this is my colleague Ramraj Chandradevan. So diving directly into what knowledge graphs are. So a knowledge graph is basically a way of representing data and the knowledge in it using the graphical data structure. So the nodes of the graph are the entities in the data, and the relationship between the entities are represented using the edges of the graph. So knowledge graphs are used in a diverse range of domains such as computer vision, natural language processing, conversational AI, web searching, even for recommender systems, and also for medical diagnosis. We would be focusing on how to fact check using knowledge graphs. So on the topic of fact checking, let's see how fact checking works when there is no automation involved in it. So one of the recent cases published by Nature is the amount of conspiracy theory and falsehoods involving COVID-19 and how difficult it is to actually fact check them and maintain all these facts manually. So this is where an automated process or an algorithm comes into play, which will help reduce the uh, confusion surrounding it. So we describe what knowledge graph is. Let's see what a flow graph is, which we would be using. So a flow graph basically uh, consists of a source and a sink node, and the information flows from the source to the sink node in this graph. So the edges of the flow graph have a capacity value, and it can have the maximum flow of information till it can be up to the maximum capacity of the edge. So a knowledge stream in a flow graph is represented using the figure that we are able to see on the right, and which basically shows how knowledge is flowing from the source to the sink node. So before moving on, let's discuss some basic of what a flow graph are. So the problem that we're trying to optimize here is the minimum cost and maximum flow problem. That from that we mean that we want the minimum cost and the flow to be the maximum when transferring knowledge from this from one node to another. For this, there are multiple algorithms. One of them is being successive shortest path that we are going to use in this research work, or that this research work basically focuses on. Another one is Edmond's Karp algorithm, which is used to calculate the maximum flow path. So before we discuss the algorithm, let's discuss what a triple is. Triple is basically a terminology in semantic web, and we use it here, or this research paper uses it to define to represent a fact. So it consists of a subject and an object, and the fact between the subject and object is called the predicate. A bottleneck is the minimum capacity of the edge. So what are the fact checking methods that are currently there before this research work? So it involves traversal of the graph. It also involves link prediction, and also learning from the data using multi-relational data set. So now we would be moving up on what fact checking is. We just saw what knowledge graph is and how a knowledge stream is derived using the flow graph. Okay.
So let's look at what is line graph is. So we start from knowledge graph, and there's an example graph here, and then we try to switch the nodes and edges so that we are going to have the line graph. And in the line graph, we have a demonstration here. And once we have the line graph, we are going to remove the duplicate edges so that we can have a contracted line graph, which is going to have weighted edges. The weights are basically the number of duplicate edges. And then from the contracted line graph, we are going to generate the adjacency matrix. And from that, we are going to define some terms called term frequency and inverse document frequency, which are the terms usually defined in information retrieval domain. And from that, we transform the adjacency matrix into a different matrix where we compute the each cell values as the TF-IDF product. And from the TF-IDF matrix, we are going to define something called relational similarity. So that's a similarity measure. We take the cosine of two vectors. The vectors are basically the rows from the TF-IDF matrix. And now we are going to define the bigger picture where we are going to define and formulate the optimization problem. First, we are going to define the constraint, one is capacity and the other one is cost. In terms of capacity, the knowledge flow through each path is going to be bounded by zero and the upper bound that is in this expression here. And then we are going to define the cost as in terms of node degrees of the incident node. And now we are moving to how to compute the knowledge stream. So we define the term specificity as a node's generalizability. And we on the right side we have the mathematical expression where we start from the defining the bottleneck as the minimum capacity of edge in a path, and then we go for the fixed supply derivation. That's basically we sum up all the bottlenecks in all the paths from subject to object. Then we define the specificity, that is for a path we take considering all the intermediate node degrees, and then we estimate the specificity. And from that we move on to finding the net flow for a path. That's basically we simply take product of bottleneck and the specificity. And finally we are computing a true score for a triplet by taking sum of all the net flow through all the paths. And we are going to solve this algorithm using SSP algorithm as an optimization algorithm, and we will be using distrust algorithm as a shortest path finding. So now that we define the knowledge stream, we are moving towards the fact checking. The existing fact checker is called knowledge linker, but in their work they primarily ignores the semantics of predicate in their path. So the authors in the relational knowledge linker, they formulated a different specificity from their existing knowledge stream specificity by incorporating three changes. First, they try to incorporate the similarity in their specificity expression, and then they mm, take all the intermediate nodes into consideration, and they did not penalize the last edge for its generalizability. By defining the new form of specificity, they are defining the true score for the triplet by just simply taking max of specificity found in all the paths. So that's the algorithm of fact checker using knowledge stream. And from this we can find some feature scopes. On the one hand we can uh, see about the incremental improvements where we can change different similarity scores, and we can also try to incorporate different metadata available in the knowledge graph. On the other side we can also look into different directions. First we can focus on improving different link prediction tasks where we mask a link and then we try to predict it. By improving the knowledge prediction task we can also improve the fact checking as intermediate results. And in the and as a second one we can also incorporate time frame and location in the fact checking. And at last, we in the previous methods we are ignoring the edge orders, but that actually matters in the fact checker, so we can also try to incorporate that in the fact checking algorithm. So that's all about our presentation, and thank you.